Hey Mark, good morning.
Hello, how are you?
I'm all right. How about yourself?
I'm well. Um, I think my um device's camera is misbehaving again.
You need to reboot.
No, I don't know what I need to do. It's an old laptop and it's starting to behave in interesting ways. Just gonna give people a couple of minutes to join, and now we'll get started.
I'll be right back. I get some order.
All right.
Are you staying up at night to participate in the IETF meetings?
No,
Yeah, me
no,
neither.
they're really not doing anything that I can meaningfully contribute to
Right.
right now, and all the videos are going to be posted online. So there was an hour and a half meeting on uh, like, tonight for Whimsy, and another hour meeting for Rats tomorrow. So it's not worth me paying a week's admission to see 2 hours of talks.
Agreed.
So, but I'm going to talk to my boss. I'm going to try and be in Vienna in person this summer because why not? And I'm not going to RSA because every time I set foot in California, they charge me hundreds of dollars every year in taxes for several years.
Say that again. When you
Every
set
time
foot
I
in
set foot in
California,
California, they charge me several $100s a year in taxes for several years after.
how come?
Well, at a certain seniority level, you have to basically pay taxes in every state you visit.
Oh wow.
Yeah. So I went to,
Income tax? Wow.
I went to, in 24, I went to like 2 days of consortium meeting in June in San Francisco.
Yeah.
And in California, in 25, I didn't set my foot in California, and I still got charged several $100s in income tax from California in 25.
Wow.
So they,
Maybe
yeah,
I should look into that. I had no
well,
idea. I,
I,
I
d- I
guess
mean,
I guess a startup salary is not, we don't trigger any of those things probably.
I don't know.
I don't know.
But
Yeah.
yeah, I don't know who else is joining, so I'll tell you what, we're just gonna get started because I want to get moving. So let me share my screen. Let's go. All right, so let's just get through the quick stuff first. I'm trying to figure out what the name of this document is going to be. So the three candidates are horizontally scaling workloads, clone workloads, and twin workloads. And I just don't know.
Um, I think that the twins are, I mean twins is usually two, but clone is kind of I don't know. It's
I'm
just
gonna
a
ask.
name, right?
Yeah. Do you wanna ask Gemini or something?
Yeah, I was about I was about to go and grab my chat GPT, tab. Where is it? I can't find my tab. There we go. This is kind of silly. Wake up, ChatGPT. Oh, I think it crashed on me.
Okay.
Anyway, yeah, let's keep clone for now, right?
Um, so anyway, I just want to go like either accept the changes or edit the changes. So basically, I'm defining clone work here. It's meaning workloads that share code, security, and configuration, other compliance related to the relevant attributes such as hardware location. Anything else I should change or add here?
No, I think it's fine.
Then it's almost there isn't much here. I'm working with someone inside the firm to try and create by end of the year an open source implementation that works in all cloud providers
Hmm.
that we can
So,
just plug into things.
so ChatGPT suggests replicas.
Replica workloads,
Yeah, replica workload. I think it's probably a better term.
replicant is so sci-fi.
Yeah, replica, CA, replica workload. I mean, I don't know. It's again, it's otherwise it's instances, copies, shards, clones, twins, so it's not very creative. But then yeah, twins and clones is yeah.
Like
Anyway,
horizontally scaling is it's long, but actually means no. Like, well, okay, I'm just gonna leave it here for now.
but when you say horizontally scaling, the purpose of the scaling horizontally is high availability, right? Or I guess it's
Well,
scalability.
horizontally scaling, yeah,
It,
because it's like containers, right? That's
right.
yeah, replica
Okay.
twin, whatever.
Never mind.
I just want to leave all the suggestions out there that we can. So all of this is basically the final form.
Nice work.
Let's see. Okay, so here's a section um for so now there's deployment considerations. Now flexible runtime integrity measurements. I'm gonna prepare and give a talk at the attestation SIG. I believe I'm on the schedule for April 21st. And I'll be talking about the fact that you know, and attestation SIG has been dealing with attested TLS relay attacks, and I've actually talked to the leads there, and I basically said, "Look, guys, you've spent so much time on this that you're actually not serving the needs of the broader needs of the community," and they agreed with me because they really rat hold on like I don't even think attested TLS is all that necessary, uh, but you know they've spent months on it. But I said, like, here is something that you actually need to worry about. The fact that for purposes of reference values, uh, we actually have at least two different constituents, maybe three. There are people who manage the hardware, and there are people who manage the software running on the hardware. And in the case of a cloud service provider, they're entirely distinct organizations. So, you know, for there has to be some solution to or some understanding that if I'm trying to decide what constitutes good evidence for a workload, I have to trust my cloud service provider to tell me the good reference values are or to accept the evidence and not put my workload on hardware that doesn't meet, the services, the provider's own requirements, right?
Right.
Uh, so the owner of the code, in this case, the workload owner, only needs to concern themselves with uh, the uh, the reference, so the evidence, the reference values for the workload itself.
Yes.
And right, so so this is one part of it. The second part of it is not all upgrades are security sensitive. and there has to be some flexibility. Like every even the minute change is going to change the evidence. Like that is the rule of the game. However, the verifier, when they map evidence to attestation results, need to understand that perhaps there is a range of different evidences that map to the same attestation result. Because if I am making some sort of a point update because I fixed, I do not know, like maybe I fixed a logging bug or something like that. I don't need to basically force the reattestation of every deployed workload. And I need to, it's, we need to, and perhaps the same is even true for hardware too. Maybe they did some sort of firmware update, but they didn't fix any security bugs. So it doesn't concern the verifier that this has happened. So I want to basically make a pitch to them. But here, this is what I'm talking about. Really, the flexible runtime integrity measurement is the evidence may change, but it will not materially I don't think, affect. So I want you to look over this paragraph. This is what I'm basically talking about.
Mhm. So to me, it goes back to um, as intended, right? That the the different components in a composite attestation are as intended, and the as intended is like the hardware provider, certifies or endorses the the hardware to be as intended in a usable, in a reliable, in the sense of, I can rely on it, reliable form, the whatever underneath the stack, underneath, the secure boot and all that stuff is as intended. We are bumping into that right now when, with TDX support, where we have to indeed trust the values that we get from Microsoft, and then indeed there's
Yeah.
the workload that is as intended. And if we do a change, then we republish, right, the workload, the reference values, and all that good stuff. And it's really the as intended, paradigm that I think works for us. That nobody who's doing the composition or verifying the composition of components has to know why the reference values actually changed, as long as they trust or can rely on the endorsement or the reference value that they get from another entity.
Right.
So
So, but that's like right. So I think you and I are in agreement.
yes,
I
I'm just
guess
I haven't read in details, and I was just telling you my words, and
yeah, yeah,
then
yeah. Well,
see if we are
take
in
a look at
agreement
what I
indeed.
wrote. Let's agree on some kind of wording,
Okay.
and perhaps we can then finalize it.
So I'm mentioning the command. I'm just concerned that it's going to be misunderstood. The mapping of evidence to attestation results should be tolerant to. I guess you're just stating the general principle. You're not implying a specific method or way of doing it. Yeah, how such visible. Exactly. Okay. The last sentence is puts us on the same page.
Yeah. All
Yeah.
right. So
And
can I accept this or any
sure,
changes
sure.
you
No,
can
no, that's
suggest?
fine. That's fine. It's a consideration, so that's fine. Yeah.
Okay. Fantastic. So the next thing is credential partitioning and sharding. And this has to do with the fact that because this is break one, break all, you may want to issue, like generate the same key for a smaller subset. So maybe, one secret key per availability zone. So that, if one gets broken, it's just the workloads in that availability zone that will need to revoke credentials for whatever. Or maybe any other mechanism. I don't want to dictate what it is. Only that it's kind of a security consideration, but it's also a deployment
Right. It's kind of a
consideration.
segmentation. It's a zero trust, right?
Exactly. Hmm.
Segmentation thing.
Hmm.
Yeah. But so you're just that's a suggestion. It's an improvement, right? One way of mitigating. Yeah. Okay. Yeah, that's fine.
Yeah, it's and again, I don't want to necessarily say this is how you do it. This is not.
Yes. Yes. I understand.
Uh,
I understand. I agree.
okay. So then I will accept any no suggestions here.
No, I mean, that's not the way we approach it, but I understand the intent, and I think it's a reasonable, mitigation, and it is it is a threat, it is a risk, and it is a reasonable mitigation.
Yeah.
So I'm not
In your case, in case of hash mesh, uh, I think there is an assumption built in that you don't have bugs in your code, right? Because it's like you have to trust the entire chain. And at least that's the impression I got when I was reviewing it. And this actually was one of my questions back at the time, is how would you deal with like creating a new or even deploying a new version if it's secure that doesn't you know cause everything underneath to
to
uh,
change.
yeah.
Well, so yeah, and we do publish new versions of the agents all the time, and so
Hmm.
but because
Hmm.
because the build pipeline, the CI/CD pipeline is itself part of the system. As
Yeah,
soon as we compile something new, it automatically updates the reference values so that the verifier knows and the deployment agent knows.
yeah,
So it's because it's all integrated that we don't have to worry about it. The passing of or the updating of all the reference values is itself part of the agentic fabric, if you want.
yeah.
And so to us, it's the only way that you can, in fact, have that agility, so that you can fix things very quickly and the reference values get reflected at the same time.
Hmm. Hmm.
The there is a at the end of the day the challenge is that if you do want to secure all information and you want to encrypt everything and you want every agent to have its own information space cryptographically secure thing, it needs to retrieve its own keys.
Yeah.
And so the idea of having different credentials for different availability zones and things like that breaks, because at the end of the day you still have to get back to a specific key that decrypts a
Hmm.
specific piece of information.
Hmm.
So it works for authentication purposes, but not
Yeah.
for information security, because you always end up, I guess I see you have encryption keys anyway. So anyways, the credential, petitioning is a good idea for authentication credentials.
Yeah.
But if you need to access encrypted data, you need to have a key that all the workloads need to be, all the clones or the replicas have to be able to access. You still with me? Did I lose you? Oh, Mark, I can't hear you. I don't know if it's me or if it's you, but I cannot hear you. And your screen is frozen. So, all right. Are we back?
Yeah, my Ethernet adapter skipped the bucket, and I just had to read like I said, my laptop is acting weird now. So I have my video. is acting out, and my Ethernet is acting weird.
Okay,
So,
as long as the human operator is still functioning, we're okay.
well,
It's
that's never
early,
a
yeah.
given.
It's at 6:20, I can imagine, yeah.
Oh, yeah, that's actually not a problem for me. I'm a rare human. I get up early just fine. Okay, so yeah, I dropped off about a minute ago, and um, I think we're back online. Everything's fine.
Yeah.
Yeah, I had to restart the driver. Uh,
All right, you want to share your screen again?
uh, oh, I stopped sharing, huh?
Yeah.
I didn't realize that. Okay.
Well, you were completely gone, I guess. I left
Uh,
the call too because I
no, I
didn't know
mean
if it was.
my I didn't. Oh, it's because my Zoom call dropped,
I see.
and then it auto rejoined. But uh, okay, all right. So you should see my screen again.
Yep.
Okay,
What
so
is
here,
ABI?
it's an application binary interface. It's
Okay.
basically how you talk to your platform, how you invoke and functionality on the. I'm surprised you don't know the term,
Well,
but yeah,
I'm not as technical as I'm pretend to be. So, and certainly not
okay,
in those parts of the systems that you are expert in. And so ABI, I was not familiar with
yeah.
it.
So yeah, ABI is like API, but for hardware.
Got it. Thank you.
Okay. And now it's recorded on YouTube, so I just said something stupid. People
Yeah.
will now know that I'm dumb too. Okay. All right.
Okay.
So
Let's just skip, delete the last 30 seconds or
that's
minute.
okay. That's
All right.
okay. I am not Pope.
Okay, that enable running workload to derive application keys for its own use.
So yeah, so it is possible to call this ABI, and it will basically say, and it gives you all sorts of options, like a bunch of flags that are very hardware specific. But it basically said if you call this ABI again and you're in the same like configuration, for instance, yeah, you didn't restart with like debugging enabled or something like this, it's actually going to give you the same key. But if
I
you
see.
are a different trust execution environment with different code measurements, then it's going to give you a different key. So it's not possible to rederive this key unless you are exactly the same thing as before.
Okay, so I'm familiar with that mechanism. I just didn't know the acronym.
Yeah, and
Uh,
that's how it's done. It basically it derives a key for you, and then lets you use it.
but that's a platform specific, right? Each chip
It's a
has a
platform
different,
specific.
it's
Yes,
tied to the ceiling type capability. Yeah.
correct. Yes,
Okay.
it's a seal. This is exactly sealing to the platform
Yeah.
thing. It's just when I use the term seal to the platform, that confused some people too.
Yeah, well, at least I knew that one. Can allow workload to store CSK. Yep. New workload should
Um,
rederive. Yep.
okay,
Unseal.
how about
Yep.
this? Actually, that
Uh,
functionality is sometimes referred to as sealing to the platform.
yep.
So for
Great.
those who recognize that term.
Yeah, like me. And then you need to have a spelling mistake at enable. Key derivation ABI that enables.
Uh,
Yep. S.
and I
Yep.
don't like, okay, so I can keep that, right?
Yep. Absolutely.
Um, Credential rotation. It's like pretty much the last one.
Yeah. I mean, makes sense.
Okay,
Yeah.
that's done. Okay. Supply chain concerns about CWK policy and verifiers. So, okay, that just removed because I just added CWK policy. What did I just undo? Hold on. What just happened? Oh, wait.
It was just a space.
Delete to do supply chain concerns. Okay, so when I said delete and accepted it, why didn't? Oh, no. Okay, so CWK access policy. Stress that it's only indirectly.
Hold on, let me make this a bit bigger. Yeah, that seems correct. 5, I'm a bit lost. What is the by the workload in order to retrieve a CWK encrypted specifically for it? Using what is the CDK
So
again?
CWK, this is the credential, this is the
That's the
CSK
wrapping.
wrapping key. So you
Yep.
actually need to get the CWK out, but it goes directly into the trust execution environment, directly into the workload.
And the CDK was what? That was a kind of a ephemeral key or something? Like
CSK
a
is the
public.
credential signing key. And the CDK is the credential decryption key. Yeah, it's
Oh, got it.
it's the CWK decryption key.
Okay, got it.
And but the thing is, but then CWK is not only indirectly, because in that case it's actually accessed directly. Like you actually get like the workload actually gets the CWK.
Well, it needs it, right? So, but
Yeah.
indirectly in the sense that it's wrapped, it's encrypted with the CDK. Oh,
Yes.
sorry.
Yeah.
Yeah, okay, got it. Yeah. In the plain text, yeah. Okay. Yeah, I'm fine with that.
Okay. So, but the credential during credential renewal, it's not accessed at all.
Credential renewal by the workload. Oh, it's not accessed at all. It needs to be
Um,
re-provisioned, right?
Hold on, let's take a look because I think we don't store CSK directly. I think we store CSK as so so CWK is generated, the access policy is set, the CSK pair is generated and stored, and then the private CSK is encrypted with CWK. So in order to
Yeah, when you generate a new, you need to re-encrypt, right? So you need CWK.
yeah, just the wrapped private CSK is returned. So yeah, so it's not accessed during the credential refresh because the CSK pair is at the key store directly.
So the workload, you mean the workload is not accessing it? Yes. Okay, got it.
Nobody accesses the CWK during refresh.
Well, the key store does, but what you're saying is
Not
that the,
during refresh because during refresh the key store has the CSK already.
we're talking about the CWK being accessed, no?
Correct. CWK is not accessed during credential refresh
But
because the signing key remains.
the signing key. So what are you refreshing? The CSK?
Refreshing is just the expiration date on the credential.
Yeah, so the CSK, right?
CSK doesn't change, only the expiration date on the issued credential changes.
Ah,
When you
okay.
refresh
Got
the
it. Got it. Got it.
credential, the
Got it.
signing
Got it.
key
Okay.
doesn't change.
Renewal. Okay. Okay. It's renewal of the same key pair. Got
Yeah,
it. Understood. I thought you were creating a new key pair.
correct. So that can be removed.
Okay.
Is that step 7? Can you actually scroll up because I've been renumbering things a little bit? Is it step 7 that wraps the private CSK?
You're asking me to pull up the
Yeah. Well, I can scroll up. It's just
Yeah, go
I
ahead.
lose.
Well, I don't have it open right in front of me, but I can go and look for it.
Okay, 7, 10, and 11. Oh, so 7 of provisioning phase and 10, 11 acquisition phase. Okay. So 7 in provisioning phase. Yes, that is correct. And 10, 11 in encrypt. Yeah, 10, that's all correct. Okay.
Okay, now I have it open, so next time I can help.
No, okay, that's fine. Where? See, that's why I was like, I was
Yeah, yeah,
losing
yeah.
my
I'm sorry about that. Yeah.
discussion, federations, traditional rotation, 7, 10, 11. Okay. If the plaintext CWK leaks due to key store vulnerability, that immediately leads to the compromise of the private CSK
Yeah, that's pretty obvious.
of the corresponding, because they're in pairs. Yeah, but no other private CSK is compromised. Okay. I think this actually completes the I added the crypto period somebody asked for that. The mermaid code is the same. All right. So this, except for this one issue, like how do we really name it?
Which
Which
is,
I can leave that, whatever.
yeah.
Um, this document is done. So now we need to talk about how to publish it. Um, basically the next steps. Do you have any? I guess this is a conversation to have with like Hank and Yogesh and whatever the rats guys. And I should probably take it. I'm probably gonna take it up to the attestation SIG as well.
Sounds good.
Okay. So um, next steps for the work group. So this is this was an important piece of work, but it's largely self-contained. Now I still want to productize it. I want it to be an open source library that you can take into any cloud provider and just run. What that means, we're still discussing. I may be able to get an engineer, a colleague of mine, to do the work. Just talked to his manager, so we'll see how that goes. Um, what can we do next here that's like reasonable and useful?
Well, I think we should have a larger group. It should not be just the two of us discussing this, right?
Yeah.
I mean, you know where I'm coming from. I think from the CCC perspective, it is my inclination to say that we should show what is the optimal case because I went along and I agree with everything that's in here, but the idea of separating all these roles and not collapsing them into a least trust infrastructure is, as we just discovered, creates all kinds of incremental, both attacks. I mean, as we said, right, everything in the verifier chain or is in fact in the TCB of the workload.
Hmm.
And the reason we ended up and we stumbled onto the architecture that we have is because we said systematically, every time we need to go and rely on something else, well, why do we need to? Why don't we just go back to the verifier? Because the verifier is the only entity that a workload needs in theory, right? Uh, you cannot have an attested workload without talking to a verifier. So
Yes.
that's the least you have to do is to talk to a verifier. And then from there, everything then collapses onto that. Say, what are the things that the verifier needs to be able to do? if we don't have to rely on another piece of software with another verification. And then now you see the pattern that emerges that becomes a recursive pattern because you can do the same thing with the verifier by having it itself talk to another verifier. So that would be my, what I'd like to do as part of the CCC, but it is very self-serving, of course. But I think it's something that we should tell the world that if you are going through the trouble of deciding you're going to have hardware-backed cryptographic isolation of workloads, then this is really the smallest attack surface that's technically possible. And then you need to start worrying about the additional attack surface that you create when you don't take care of the verifier chain with the same level of care.
Yeah. Are you
So
talking about basically the fact that maybe I misunderstood you completely, but clarify. You're talking about the fact that here we're introducing key store and credential authority, so our TCB has gotten a lot bigger than just the
yeah,
verifier.
yeah, you basically by separating the different roles and not collapsing them into one actor, you basically have to introduce all these other, as we said, right? Every actor needs to authenticate itself to every other actor, needs to do key exchanges, needs to generate its own keys, manage its own keys, and all that. If you collapse the functions of identity, so attestation, verification, identity, credential issuance, and key store within the verifier actor, then you, by definition, have minimized the the attack surface because those
Yes.
things don't have to talk to one another, all within the same boundary.
Yeah.
Um,
So there is that sort of one way of looking at it. By no means saying it's invalid. It's very valid to say it that way. I also note that having verifier and credential authority and key management all in one box. Uh, I would need to talk to people who manage such things and worry about their compliance, see how they feel about, you know, like usually, like what if, I actually don't know if it's usually or not usually, but what if an organization says, well, these are our key management people, these are our credential people, and these are our verifier people. And they don't necessarily, if you we have all three of them manage the same service, they'd be stepping on each other's toes, and maybe they have different policies in different jurisdictions. Like I don't even know how this conversation will go, right?
I, I hear you. I mean, that's the legacy thing, right? And so and you explicitly said it in the beginning, right, of this exercise for the TW, I mean the clone workloads, that this is a real world, use case that is immediately transferable. We can just go and do it. What I'm saying is that at the other end of the spectrum is if we were to design a system that is inherently as secure as can be, what would it be and what would it look like? And then, I'm not saying that we cannot break away from that optimal architecture, but then you do it. I mean, what's interesting, we live this every single day. When we make a change in any one of the actors, we are asking ourselves two questions. The first one is, well, actually, it's one question with two facets. Is it better to do it within the same actor, or should we create a separate agent? And what is
Yeah.
the delta? What is the compromise that we are introducing?
Hmm.
Now you have an explicit conversation about attack surface and level of trust required. And that to me is the interesting exercise. I mean, at the ATF, one of the challenges I've had over the past 2 years is indeed that security always comes second after reuse of existing standards, for instance.
Yeah.
And the problem with that is that you never then revisit the underlying assumptions of those standards. And if you don't revisit these assumptions, you cannot introduce things that are fundamentally better, like confidential computing. And yes, if you use confidential computing as a component or an ingredient of an existing architecture with existing protocols, then you miss the point of, well, guess what? You should start with the most secure posture and then you should build from there. And so you discover identity should be the first thing that you should do within confidential computing, and then authentication. And then, then your verifier needs itself to be built in the same thing. So anyway, so that's I think from the CCC perspective, we should be opinionated and just say this is an optimal architecture, this is the real world architecture, and then there's a spectrum in between. And every
Yeah.
time you move from, to the left or to the right, you know that you're making compromises and you just need to explicitly
Yeah.
have your assumptions.
All right. So I'm not challenging anything you said, but let me sort of, there's only one starting point, unless you're building a brand new enterprise. There is only one starting point, and the starting point is whatever it is that you got.
Yes.
In a meeting at work yesterday, we were doing our monthly conscious computing sync, and I was explaining to people, which actually mirrors something that what you just said, and that's a realization I had within the last year. Data and use protection is a side effect. It's a very, very nice side effect. But the thing that is really, really important for an enterprise these days is workload identity. And confidential computing makes workload identity ironclad effective.
Yes.
That I absolutely know that I am sharing my data with the right workload.
I mean,
And
to the
that's
best, to the, yeah, this is the state of the art,
that's
essentially, right?
basically the gold standard. Yeah.
That's right.
And I
The state of,
basically said, look, so uh, the first step that our organization needs to do is to standardize on a workload identity architecture. Irrespective of security, workload identity architecture. And the only other thing there is that workload identity architecture must be free of bearer tokens.
yes.
Okay.
Yeah.
Now, there may be some compromise here because this particular vendor supports nothing but API keys, and we have no choice in the matter. But
I mean,
uh,
which are you talking about specific vendor that you guys already are doing? I mean,
yeah, we work with hundreds of vendors.
yeah, yeah,
Okay. So once we do that, now it could be whimsy, but it could be something else. Doesn't matter. But there is some workload identity architecture that utilizes, bound tokens. The step after that is you in a large organization, especially an organization as large as ours, you're not going to mandate uplift to confidential computing, let alone an ordered uplift where you have to do servers first, clients first, and like there's not going to be any rhyme or reason to how you move to it. So if workload A talks to workload B, talks to workload C, it ought to be possible to turn the consensus computing on at workload B with a zero blast radius as far as how A and C operate, because they are going to be different organizations.
yep,
And you cannot risk breaking them. So one day they wake up, USB is running in a consensus computing environment, and they didn't know. They didn't find out. They don't
yeah. I
care.
understand. I'm with
Right.
you on that thing. Yep.
So in a organization that moves to the confidential computing in this piecemeal fashion, it will be a really long time until the last vestiges of legacy are,
Yeah,
no longer. Like we
yeah,
still operate on mainframes, okay?
yeah, yeah. No, I mean, I'm totally with you. But at the same time, the core new things that you put in to be able to, for instance, the identity infrastructure for your identity workloads, for your workload identities, right? They themselves should be, state of the art, right? They should be running in confidential computing environments. Otherwise, you're basically saying, I'm going to do all this because my goal is to eventually migrate some of my, children workloads, onto these new confidential computing infrastructure, machines. And yet your identity infrastructure itself is the weak link now. So what you need is, although of course you live in a world of, highly insecure compared to the state of the art, the gold standard. The back end of your identity infrastructure for workloads should itself be the gold standard, because otherwise, when you're at the end of your journey, it will be your back end will be the weak link. So that's what I'm saying is it's almost like, you're building a bridge to go from here to there. You can start from, where you are today, and then you basically implicitly carry assumptions and preconceived artifacts because you have them and it's more convenient and people just continue to build on legacy. Or you go on the other side of the river and then you start building the bridge the other way. And then, yes, you will meet in the middle somewhere, and yes, there will be some compromises, but at least you know that where you land is where you want it to be. And so to us, that's what is really important, especially with confidential computing, because it gives you such a drastic,
Yeah.
reduction in attack surface and in trust required. It's a step change. It's not incremental, right?
Yeah.
It's not it's black or white. It's not even close. The level of security you get. So. And again, to us, we live it every day where we know exactly the pieces that live outside of our infrastructure. We know that they are orders of magnitude less secure than what lives inside. And so that's why we're constantly just moving things in. Hence the move to TDX and to be able to do the CI/CD pipeline itself in the confidential computing environment. And that's how we know that we have to rely on some endorsements from Microsoft, and we accept it because that's the real world. We cannot have our own physical hardware yet, and so we live with that. But at
Yeah.
least we know exactly that what we accept where, so that then we can flag that and then over time just migrate them in.
Right. I guess my only comment, if I were to compress it into a soundbite, is an architecture that assumes that an ecosystem here is going to fail,
An
right? So,
ecosystem is going
like
to,
an ecosystem as an architecture that assumes that everything, like every workload is surrounded
of
by
course.
workloads follow the same architecture.
Yeah, that's not going to work.
Even
Yeah,
even the thing I said about we need like a firm-wide workload identity that utilizes bound tokens is an aspirational statement. Right. It just needs to be widely enough supported because, as I said, there will be somebody who still uses API keys and I can't help them. But, I can't prevent them either because business requirements, right?
that's right. That's right. So but you build a core infrastructure and then you compromise at the edge, right? When the optimal infrastructure needs to explicitly degrade because you need to deal with some legacy stuff. You don't take the legacy stuff and then perpetuate it and bleed it into the new stuff that you're building. Otherwise, you've hurt yourself even before you even get started.
Yeah.
Anyway, we're saying the same thing. We need to take care of the edge. I mean, you had a few months ago. You talked about what was it? The things that don't change and the things that do change. I forgot. You were much more eloquent about it. But that we need to assume that the things that need to change you keep it at the periphery of your architecture, because that's the stuff that you need to deal with, the ever-changing things. But the core
Yeah.
infrastructure should be inherently, if you build anything with the hope that at some point a vast majority of it will be on confidential computing, then the core of the infrastructure itself needs to be, this state-of-the-art thing. So that's how we started. That's where we're going,
Yeah. No, I mean, you
and
you
that's
guys
how
are
we
doing
approach
God's
it.
work. Like,
Right. Right.
I just come from the boring default world where,
Yeah, but
uh,
that's why now we support SPIFFE, for instance.
yeah, 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 yeah.
Right. It doesn't make we support OpenID Connect. We support, SAML. I mean, talk about it,
Yeah, yeah, yeah.
supporting legacy. We support SAML, but internally it's all CBOR and it's all, WebSocket and it's all, optimized for and it's Rust. But hey, we still support SAML at the edge, right? Because we have to. But we optimize the core and then we deal with the legacy stuff at the edge so that when that stuff goes away, we fall back onto something that is better.
Yeah.
So. And
All
I,
right.
so I think that would be my preference. If we could work on something like this, but I understand, I'm just one voice, and so it may not be what the group wants
No,
to do.
I mean, this is not a straight democracy. I think ideas have different weights. Okay, so uh, uh, please think between now and next week what the next steps for the SIG should be, because I don't want us to stall after completing a nice piece of work. Uh, it's already tough enough pushing the GRC SIG forward when like almost nobody
I
shows up to meetings.
I know it's remarkable the amount of energy you have in putting this and doing this work. So thank you for that.
Yeah,
Unfortunately, as you know, I'm a kind of a weak participant here because I'm trying to start something else, and my
yeah, no, of
bandwidth is
course.
very limited. I can't really contribute or lead this work. That's the other reason why, I would like to see this conversation going in the direction that is self-serving, but I won't be able to lead because I'm trying to
Yeah,
build a
but
company. So
right, I understand. So I just need to understand what the next topics are going to be.
understood. I will, where I stand, and I will, continue to think about it,
Yeah,
but
yeah, yeah.
most likely we'll land in the same place next week. So,
All right.
oh, next week actually is RSA, so I'm probably not going to be there.
Okay, maybe I'll cancel next week's meeting just so that I also have a chance to regroup and think about it.
Sounds good.
All right. Thank you,
Mark,
Manu. Thank you for your help.
take
Okay, bye-bye.
care. Thank you
Take
for the
care.
work. Be well.
Bye.
Bye.